An emergency, a signal for help, but who has the priority? Or look at it another way. Here, as if you have to be told, is a concept, congestion. Somewhere out there is an ambulance with a mission. But no mission is going to be fulfilled here in this congested environment. Apply these concepts, signal, interference, congestion, mission, to military signal communications. The increasingly serious problem of radio frequency interference threatens the ability of a commander to command. It is against this threat that the efforts and resources of the Electronic Environmental Test Facility at Fort Huachuca, Arizona, are directed. This old Indian Wars fort, once the home of the famous Apache scouts, is now devoted to the modern methods of electronic reconnaissance and electronic warfare. As a result of the Defense Department's concern over radio interference, the newest region of investigation is in this fine Arizona sky. Here in the sky, in an intangible electronic environment, warring forces created by ourselves and not the enemy threaten catastrophe. It is here we must combat them. This is the Invisible Battleground. Congestion of the electronic environment, with the same self-jamming result as any motor traffic tie-up, has had an explosive history. Only yesterday, it seems, it was a rural environment. In the early days of radio, natural phenomena and its own weakness were as signals only enemies. This didn't last long. With the appreciation of the reflective characteristics of the ionosphere, the skywave came into use. Power, numbers, employment increased rapidly. The rural environment started to go urban. World War II brought an electronic population explosion, not only military but civilian. The existing knowledge of radio was exploited to its fullest extent in terms of number and power. Radar also appeared. The region of microwaves was invaded, and thousands of germinal ideas were planted for the future. Meanwhile, the electronic environment was filling up. Then came the harvest of those thousands, perhaps hundreds of thousands of germinal ideas. After World War II and Korea, in the military field alone, scores of radar types appeared: air navigation and traffic control, fire control, tracking and space probes, combat personnel surveillance radars, short range, medium range, and long range, which, true to military tradition, can determine the sex of the object under study, although, of course, this is not its sole function. In signal communications, radio relay long ago joined the jam. New scatter techniques, single sideband transmission, radio teletypewriters, and in new fields, unmanned radio-controlled drone aircraft, transmitting combat intelligence to the field commander via television. The rub is that each of these new emitters use greater power than past devices and usually require a broader band of radio frequencies for operation, factors which make them sources of interference. In addition, new receiving equipments are usually of much greater sensitivity than old types and are therefore more vulnerable to radio interference. The fact is, we have created a monstrous bumper-to-bumper condition in a limited environment. An environment already overflowing with hundreds of thousands of devices which have been skillfully designed and tested for their specific missions, but not for their compatibility on a thoroughly congested battleground. Unless this massive electronic emissions is controlled, the step from chronic inconvenience to catastrophic signal communications breakdown is short and unpredictable. Order in this electronic environment has traditionally been achieved by separation. Frequency separation is utilized if two emitters or nets of emitters must operate in proximity. Distance separation is utilized if two or more nets must use the same frequency, but not interfere with each other. Time separation or time sharing is utilized if they must use the same frequency and operate in proximity. These are the three basic and inescapable principles on which every system of radio frequency assignment are based, no matter how complex. This complexity is emphasized by the fact that the field army of the immediate future, from division through corps up to Army Command, will have a total of 75,000 electronic emitters in an area approximately 100 by 100 miles. This sheer mass places a heavy burden on the radio frequency spectrum. The spectrum is a fixed natural resource. It cannot be changed or expanded. It can only be shared, juggled, or in many cases, traded. Since the beginning of World War II, the task of frequency assignment has grown from the part-time duty of a junior officer with the help of what came to be known as nosebleed charts to the highly demanding and frustrating profession of frequency engineering. Frequency engineering includes, among its functions, almost daily collective bargaining for channels in which to conduct defense operations, vital research, and vital signal communications. The old simple rules of separation in frequency, distance, and time have simply gone out of date.
Record special observation.
Is this environmental congestion truly serious? Or is it merely a chronic inconvenience we can live with? You be the judge. Here is a standard Army receiver, a typical sensitive instrument. This is a visual representation of what we hear. Below it is hash, composed of many undesired signals transmitted on the same frequency to which the receiver is tuned. When they are combined, the result is simple radio interference. We can hear it. It can completely overwhelm the desired signal. It may be many signals, or it may be just one. The interference can be intermittent. One or many. Hash or a single intruder. The sense is lost. Intelligence is fragmented. Command control is lost. Radio interference is one of the hazards of the battlefield. It is simple to think of an electronic emission as a two-dimensional, point-to-point line between two stations operating on the same frequency. Actually, an infinite series of electromagnetic waves is propagated in at least three dimensions, with length, width, and thickness. The desired emission will also inevitably contain spurious frequencies, which are harmonics of the fundamental, and other spurious emissions which may jam equipment. This problem is complicated by the fact that the complete spectrum signature of most of our equipment is still unknown. The third factor, interaction, is potentially the most dangerous of all. Its basis is the familiar and useful heterodyne action of electromagnetic waves encountering each other in a detector. Signals of differing frequencies on meeting in the detector add, subtract from each other, divide, producing several differing frequencies at a time. The principle is employed in every modern superheterodyne receiver to turn any incoming signal into a standard intermediate frequency, which the receiver then processes into an audio signal. Do we always need a superheterodyne receiver? No, any detector will do. Nature and man provide many. We have all heard about old steam radiators suddenly becoming radio receivers. This new computer, destined for field use by the Army, is neither a transmitter nor a receiver. It is, however, an electronic instrument, ready and willing to become a detector if the proper emission comes along. Interfering or spurious emissions can disrupt its operation. This is like giving a field commander an intelligence report from which every second sentence is missing. Interference, of course, may not produce mechanical evidence of its presence. It may get into the act mathematically, inserting small errors in the computations, which can be magnified into disaster on the battlefield.
Pine Street Airport. 4444 1811 Pine Street Airport.
There is a strong suspicion that interaction between a taxicab dispatch transmission and the command control equipment of an experimental missile many miles away
22, where are you? Passenger Fulton Main is blowing his top.
resulted in the loss of the missile. Ironic, yes. Also dangerous and expensive if stray electronic emissions can interfere with the control and application of modern weapons systems. We know they can, and we take the proper precautions against known emissions. We can only do the best we can about emissions we do not know about, our own and not an enemy's. Like that nurse in the nursery, we need to know what is interference and what is not. The Department of Defense has addressed itself to this problem through the Joint Radio Frequency Compatibility Program, which embraces all of the services and is aimed at a general assault on the environmental situation. Each service is also charged with investigating its own peculiar electronic environment, and the Field Army's peculiar environmental problem derives directly from its mission, which demands extreme mobility and flexibility in its operations. Therefore, its electronic environment is dynamic. The type Field Army may be committed to a wide front. It may be segmented by nuclear contaminated areas through which nothing but a radio signal can pass. It may be compressed on a narrow front. This environment changes in size and density with every one of its own and the enemy's actions and reactions. It alters with every decision of its commander. It changes as a result of the combat intelligence gathered by the Army's own electronic equipment. And it is in the crucial moment, when hammer strikes anvil, when command control is most vital, that radio interference may be the most deadly. It was to this problem that a study group addressed itself at the United States Army Signal Research and Development Laboratory, Fort Monmouth. Support was drawn from many eminent universities, institutes, and commercial contractors engaged in the study of radio frequency interference. A typical problem considered was the assignment of frequencies for a field army. It required 8 weeks to devise a frequency engineering plan which on paper would result in a minimum of radio interference. A great mass of data concerning the known spectrum and propagation characteristics of current Army communications equipment was gathered, and the problem was submitted to a high-speed computer. This mathematical computation indicated a high probability of radio interference at every level of command. The final report of 4 Project Monmouth studies recommended that An experimental area be selected where concentrations of equipment for all services could be installed and operated under closely simulated wartime conditions. The need was for a field validation of laboratory analysis, and the even more urgent need for data up to now unattainable. On the advice of the Army Scientific Advisory Panel and the Chief of Army Research and Development, a plan was drawn up, funded, and development begun for the Electronic Environmental Test Facility. The first prerequisite of the EETF was an area relatively free of electronic emissions. This land, largely in state and federal ownership, arid and almost unpopulated, existed northward and westward of Fort HUACHUCA. Of this expanse of several thousands of square miles, only a few hundred acres would have to be available for test sites scattered through the area. A realistic tactical program was prepared, and plans were made for the actual deployment of field army transmitters to create a real electronic environment in which to study radio interference. The development is centered on Gila Bend, Arizona, 170 miles from Fort HUACHUCA. A 2-year program will evolve in 3 phases, each to be a building block for the phase to follow. Phase 1, small units operating in an environment generated by the next higher echelon. Phase 2, a combination of divisional units operating in the environment of a division. Phase 3, the division in the environment of a corps in isolation. In effect, evolution of all 3 phases began at the same time. The first step, after determining the units deployed in the tactical program, was the determination of the number of emitters required. The forward test site, representing a small unit command post, would be the core of the facility. The deployment of tactical equipment for actual transmissions would be realistic around the forward test site. Beyond this area, certain low-power emitters have no electromagnetic impact on the environment at the test site. These could be eliminated. In adjoining areas, nets operating on a single frequency could be considered a point source. Only one station of each net would be operating at one time. One station on a heavy-duty cycle can represent the entire net. Directional emitters not oriented toward the test site also could be omitted. Others, however, with minor lobes oriented to the test site or augmented by such factors as obstacle gain would, of course, be included in the environment. In addition, units in reserve were assumed to be observing radio silence. This approach reduced the actual number of emitters needed to generate a realistic core environment from thousands to several hundred. In profile, the EETF looks like this. However, only communications emitters are included in this initial effort. Thus, in the central area, 27 emitters represent 42 actual transmitters in a reinforced rifle company, and 13 represent 71 transmitters at the division advance, including medium artillery and division area signal communications. In the adjoining areas, 2 sites with a total of 32 transmitters represent 179, including those of a rifle company, battalion rear, and an artillery battery. In the flank company area, 11 transmitters represent 54, while in the adjoining battalion area, 41 emitters on 2 sites represent a total of 219 transmitters capable of causing interference at the forward test site. To round out the picture, 1 site with 26 emitters represents a total of 229 in 2 battalion areas of the adjoining division. A similar, but not identical deployment has been developed for the division on the left. This overall deployment represents a specific deployment of forces at a single instant of time. It is our starting point on which we can build more active and fluid tactical situations.
Heavy vehicle concentration encountered 400 yards due north of Hill 15.
In the spring of 1961, Phase 1 tests were completed. These company and local environment tests were manually operated. Although being infantry emitters, they called for a little footwork too. They did two things: validated the principle of emitter reduction and confirmed suspected areas of interference.
Break. 200 yards.
Authentication is Yankee, Yankee.
Test and control equipment was ordered. Tactical equipment was modified slightly for automatic testing, without, however, altering its basic emission characteristics. To extend the findings of the test facility to other areas, different soil and terrain conditions, and larger military concentrations, use is made of an interference prediction model. Such a model is a combination of measured characteristics and theoretical equations, which describe the passage of radio energy from each transmitter over the intervening terrain and on to the receiver. The facility validates the model, and the model extends the usefulness of the facility. A spectrum signature program, a project of the Field Test Directorate of the Proving Ground, is also underway. This will feed Army equipment data into the Department of Defense Joint Radio Frequency Compatibility Program. This project will also contribute data to the radio frequency interference prediction model. Just how far has this program progressed? Maintenance facilities are housed at Gila Bend. The forward test site building has been prefabricated from plywood and is installed below ground level so that only its receiving antennas project into the electronic environment. Frequency monitoring equipment operates at the periphery and within the EETF area. Outgoing as well as incoming signals are detected and corrective action taken where possible. 24 environmental generator vans have been installed in their sites. Each environmental generator consists of an Army transmitter and a test control box. Each emitter has been sited so that neither antenna, power cables, nor supporting guy wires cause abnormal interactions in the environment. One building at each site is portable. Even its stack is checked with a field intensity meter, for any piece of metal can become a spurious contributor to the electronic environment. How does EETF operate? It operates automatically by means of a carefully prepared punched card program. Here is a specific series of tests. Any emitter on any site may be designated to be one end of a test link. This emitter will be modulated with a 950 cycle per second test signal. The other end of the test link is a receiver at the forward test site. Test number 1 of this link will be under maximum environmental conditions. All the other emitters in the environment will be turned on and automatically voice modulated. Thus, the 950 cycle test signal must compete with a multitude of other signals coming from all the other environmental emitters, which are operating on hundreds of different frequencies. This test will determine if there is any interference degrading this link and the maximum extent of the interference. If interference is detected, the second test begins a meaningful sequence which seeks the sources of the interference on the link. In this test, only one of the environmental generators may be turned on. In subsequent tests of the same series, various combinations of environmental generators will be turned on. Thus, in test number 2, the 950 cycle test signal competes with only one other signal. In subsequent tests, it will compete with one or more different signals from one or more different emitters. Each test takes 30 seconds. From 500 to 1,000 tests can be run daily. This is test number 1. An automatic signal from the master sequencer. passes along a hard wire link to one of the environmental generator vans. A deck of punched cards turn the desired emitters on and verify proper operation for the first test. A malfunctioning emitter turns itself off, giving an alarm and causing a malfunction indication on a card. This card also provides off-on information for test number 2. Total 7 seconds. Now the test link transmitter is modulated with a 950 cycle test signal. In the van, a pre-recorded magnetic tape voice modulates all the other emitters on the site included in the test simultaneously.
This is Industry Van Site 11 at Gila Bend, Arizona.
The received 950 cycle signal is compared for degradation against the tone originally transmitted over the test link by automatic interference detection equipment developed especially for the EETF. Interference check time, 22 seconds. The result is then transmitted by the interference detection equipment to a card punch machine. The interference information is now punched into the test card. This takes 1 second, completing test number 1. Total elapsed test time, 30 seconds. Each subsequent test follows exactly the same cycle. The data transmission system is less sophisticated. The punched cards are transported manually from the van sites to a central collection point. Simple, effective, and dusty. The raw data is reduced and processed at Fort Huachuca. This is new information about the electronic environment. Most of the EETF tests to date have been aimed at validating, developing, and modernizing the original concept. At the end of the initial 2-year period, the EETF program will be able to move toward its goals from its inception in 1960. What are the goals of EETF? To reveal the incompatibilities in Army equipment and systems, to recommend modifications to reduce interference, to provide a firm basis for realistic design standards for new equipment, to test Army frequency assignment plans, to test newly developed equipment in the electronic environment, full-scale testing of division communications equipment operating in the environment created by core communications equipment will be completed in 1962. Future expansion of the EETF will include drone flights over the area to ascertain effect of drone electronic systems on the environment and vice versa. The effect of non-communications emitters, radar, jammers, countermeasures equipment, certain Navy, Air Force, and allied equipment, as well as enemy emitters on the environment and vice versa. In addition, future expansion of the EETF will include modification of the tactical program as required.
Of intelligence in hand, the scheme of movement of the aggressor is now clear.
Atomic weapons. Authority to employ atomic weapons has been decentralized to division commanders attacking Area AB4.
By the methodical buildup of the facility, by experiment and study of new data, it is planned to meet the threat posed by a congested electronic environment, so that the voice heard on the invisible battleground is not the voice of confusion, but the voice of command.